Okay, welcome back to Dublin Academy of Maths. Now you'll find me at dublinacademy@gmail.com or dublinacademyonline.com. Okay, now here with today we're on Leaving Cert Early Level Maths Series 8, Episode 2, Paper 2, Volume. Okay, now volume is measured in units cubed. Okay, so whatever unit you get, you must remember it's cubed, right? Because it's three-dimensional. Okay, so if you're stuck, cubed is three-dimensional, you can see through it. Okay, so this is a box, right? You got length by height by width or breadth, they might call it. So volume is length by height by width. The volume of a sphere is 4/3 pi r cubed. Using pi, they might say expressed in terms of pi. We're going to do a question similar to that. SA is surface area, 4 pi r squared. Okay, area is in units squared. Okay, we're dealing with a hemisphere now. Hemisphere is half a sphere. Now if you want to work it out, you know that it's half of it of 4/3, so half of 4/3 goes into it, so it's 2/3 pi r cubed is the volume, not the surface area, because the surface area takes up the circle as well. Okay, so remember that surface area of a sphere is not double the surface area of a hemisphere. Okay, moving along here, we've got a cone here. Well, I'll move on to the cylinder because I want to get to the cone. Cylinder is volume is expressed as pi r squared h. H is the height, r is the radius. Surface area is 2 pi r h. Now, before I get to the cone, all these are found on page 6 or 7 on page 7 on the tables. Okay, page 7 is one on the tables at the issue. You should have them anyway. Okay, now we're going to do we're going to have a look at this cone here, right? So there's a few things I just wanted to get out of the way before we start there, because I did mention it the last time, and that was that let's look at this photo here. We look at this cone, right? So we have a cone, and we're asked to find L, because sometimes one of the questions was expressing the surface area in terms of L. Okay, or you have to find L. So we're told that sorry about that, but say this is 3 and this is 4 and it's a right angle triangle, and we have to find L. Okay, so we use Pythagoras theorem. L squared is equal to 4 squared plus 3 squared. L is equal to the square root of 4 squared, which is 16, plus 3 squared, which is 9. L is equal to the square root of 25, which is equal to plus or minus 5. We don't take the negative, can't have negative area or lengths. So the length is 5. Okay, so we're to find the surface area, curved surface area of pi, which is pi r L, the surface area, curved surface area. We now have L. Okay, and we can do that with areas of triangles, and you might remember that we had a triangle here before, and we were told we dropped the line here. Okay, so we're given the base, say, is 8. Okay, and say this is 5 and this is 4 again. Okay, well, we won't say this is, say it's 8 to there, and it's cut halfway, so it's from there to there is 4, and from there to there is 4. Okay, and it's the same principle again. If we want to find the height, we need to find the height of that triangle in order to find the area of that triangle. The area of the triangle is half the base by the perpendicular height. We don't have the perpendicular height, but we can find the perpendicular height because the hypotenuse is equal to the sum of the opposite two sides. Okay, because I'm going to call it x, okay, or the height. So we could just work it out by manipulating the formula. 5 squared minus 4 squared, h squared, that should be. H is equal to the square root of 25 minus 16 is 9. H is equal to 3. Okay, whatever unit length it is. Okay, so that's the length from there to the perpendicular line. Okay, and it's the same with parallelograms. It'll come into it as well. So the cone is something similar. Okay, so if you're asked to find the curved surface area, you will need L. Okay, so that's really the point that I'm trying to get at here now. But moving on, and moving on, we'll do a question. Now it's the same question as the last one, but we're moving on to part C of it. And it says the volume of a sphere is 36. The volume of a sphere, so this is 2012 and it's section C. Okay, I've given it before which one it is. So it's 2000 paper 2. Okay, so it's paper 2 and it's 8C. That's it, 8C. And it says the volume of a sphere is what is it, 36 pi centimeters cubed. Now they've given you in the terms of pi. Excelente. Okay, so that means you're not probably dealing with decimals or fractions. 22/7 as a representative of pi. And it says find the radius. Find the radius of the sphere. Okay. Now, first of all, what's the volume of a sphere? That's the thing you should be going. You should go to your books and you can find out the volume of a sphere in its expressed as an equation, and the volume of a sphere is 4/3 pi r cubed. Okay, and you get that in your tables. Now you're saying that this sphere, okay, so best thing to do is to draw a little circle, okay, or a diagram to represent what you're getting at here. You're not really told anything, but you know that you find r. But you're told that the whole of that volume is equal to 36 pi r. So this 4/3 pi r cubed is equal to what was the 36 pi. Okay, now this is a case of manipulating the formula, and I just go along and I manipulate the formula to find r, because I don't know what r is, but I'm told everything else. Okay, so that should be 36 pi. So I manipulate the formula, okay, and I've done this before several dozen times throughout the papers, throughout the episodes. So I'll cross multiply 4 all over 4 times pi. Okay, now that's 36 times pi. I just cancel them like that. Okay, and I'm left with so r is equal to the cubed root. Remember now, you're bringing it across and you're opposite the function, and this is 3 times 36, and it becomes all over 4, which it becomes 27. Okay, nice number there. The cube root of 27, go to your calculator and you have this function here and you know where it is. I've already shown you how to do this. You know, you do your number, you put in 3 or whatever way your calculator works. I don't know, but I know how mine works. Anyway, we know what by what will give me 27. We know it's all by 3. Okay, so 3 by 3 by 3. Okay, so in other words, the radius is 3 centimeters. Okay, so r is equal to 3 centimeters, because it's all represented as centimeters. Okay, I hope you get that. Now cross multiply, manipulating the formula. You'll find that in series 1 on algebra, and you might find it. You'll find it everywhere on the papers, really. You know, so that's that question now. And the next part of the question, it says when the sphere is fully immersed in a cylinder of water. So, and it even draws you out a diagram. Okay, so when it's fully immersed in a cylinder of water, okay, it says the level of the water rises by 2.5 centimeter. Water rises by 2.25 centimeters. Okay, so it rises by 2.5 centimeters, and that means that we have to start using our head here. Okay, so at one stage, somewhere along that line, before that cylinder came in, the level was there. Okay, and when we put that sphere into the water through displacement of water, which is Archimedes' principle. Yeah, do you remember Archimedes? Eureka! He shouted when he discovered that water in volume can be represented by the displacement of water. Okay, if you can get what I mean. So if you jump in the bath, you know the stuff that goes over the line, you know that's your volume of water. very simply put. So that's 2.25 centimeters. And it says, it doesn't tell you anything else. It says, so the volume, so we're looking at this new height here. Now, I know that the volume, what's the volume of a cylinder, first of all? I want to get that out first, because I want to be able to look at things and to be able to decide what we're at here. Okay, so the volume of a cylinder is, looking through our papers, looking through our things, is pi r squared h. Okay, so pi r squared h. Right, and we don't seem to have anything else here, and that we're told now that we know what the height is actually, because this is now, this sliver or this slice has now become a short cylinder. Do you understand? So you're taking this out here, and it's actually a cylinder in its own right. Okay, and this cylinder represents that's the height, the new height. And this volume, I know what this volume is, because this volume is the volume of the sphere. And the volume of that sphere was 36 pi centimeters cubed. Okay? And I know that I can relate this to that, and from that I can find what my radius is of this new sliver or slice of cylinder. Okay? So this rise is all related, has been defined, okay, in such. So I manipulate the formula, and let's have a look. So that's 36 pi. So pi, I'll move this up here. Okay, so pi r squared h is equal to 36 pi. So pi r squared h is equal to 36 pi. Alright, so I'll just move that. So I've explained this all to you, and I've told you where I've gotten it from. Okay, I knew the height. So my new height is 2.25. I don't know the radius, and I'm leaving pi as pi, because it's all represented as pi. Right, now I'm going to rub that out again here. Now I hope you see that. So I'm saying that the volume of the cylinder, the new cylinder, is equal to 36 pi. And I know that my height, which has gone up by 2.25. And I manipulate the formula. Okay, so I manipulate the formula, and I get what R is equal to. R is equal to 36 times pi divided by 2.25 divided by pi, and it's r squared, so it's going to be the root of all of that. Okay, and they cancel. So you divide that into that, and there comes an answer, and it becomes the square root of 16. Okay, and the answer is plus or minus 4, but because we're dealing with positive here, area is positive, and it's in real life terms, so we're dealing with positive 4 centimeters. Okay. Now that's quite a good question. So you know how to manipulate, and you know how to imagine things and to draw out these things and to try and make some sense of them. The whole thing here is to draw the diagram and try and get your brain to interact with the diagram. If you can see the solution, fair whack to you, but if you're stuck, draw the diagram out. Now let's have a look at these questions. Now, there's no other part to that. No. That's the radius of that. Okay, the questions here. The volume of a hemisphere is 486 pi centimeters cubed. Find the radius of the hemisphere. Okay, now you just use the volume of a hemisphere and you interrelate it with this, and you manipulate the formula to find R. D, it says, so this is part of this as well. Find the volume of the smallest box that the hemisphere will fit into. The smallest box. So you can imagine that it's only one hemisphere, so the diameter is going to be equal to the width of the box. Okay, the diameter is twice R, twice the radius. There's your clue. Right, now do the questions. Get them done. Thank you. Take care.